Hello everyone, today we'll start by looking at the line of best fit. When we look at the line of best fit, it needs to be in the center or as close to as many points. The first step in finding the line of best fit is to take your data and plot it on a graph, which I have already done. So here we have our graph with smoking and obesity rates from 1982 to 2007. So what we're going to do is find the line of best fit for obesity, which is labeled in red. What you're going to do next is use a ruler or a straight edge and try to find the best place to place your line in relation to your points. When you find the perfect place to place your line, you may draw your line as so. Now we need to find the equation of the line. To do that, we need to try to find 2 points that lie the closest to the line. That will give us more of an accurate representation for your line. So our 2 points are 8.25, 24 and 21, 40. So to find the equation of the line, we're gonna need to find the slope and the y-intercept. So first, to find the slope, we'll start by using the slope formula to find the slope of our graph. To do that, we will use the 2 points that we just picked. What you can do to make this easier for you is label the points with the x and y coordinates. Once you have substituted your points into the formula, calculate the slope out to 2 decimal places. Now that we have our slope of m equals 1.25, we will use one of the points that we chose earlier to help us find the y-intercept. Use the x and y coordinates along with the slope to substitute it into the linear equation of y equals mx plus b. Simplify and solve for b. Once you have your b value, stick the slope and the b values together into the equation. That will give you the equation of the line of best fit represented by slope-intercept form y equals mx plus b. Now I'll be showing you how to find the linear regression for this graph. Once again, we will only use the obesity data. Here I drew a chart that represents the data from the obesity line on the original graph. So our main goal is to find this equation, y equals a plus bx. A is going to be our y-intercept and b is going to be our slope. There will be 2 different formulas in finding a and b. However, before that, to make things easier later on, we'll find what I call the sums. Here I wrote them down all in order, and by the way, this E is a Greek letter that just means the sum of. The first step is to count the samples. In this data, we have 6. The next thing you're going to do is find the sum of x, meaning you have to add 0 plus 5 plus 10 plus 15 plus 20 plus 25, and that will give you the sum of x. Then you have to do it for the sum of y, then the sum of x squared, and so on and so on. So here I just rewrote all the information that we have to make it nice and neat so that we can find A and B with the 2 different formulas for A and B. So first we're going to start by finding B using the formula of B equals n times the sum of x times y minus the sum of x times the sum of y over n times the sum of x squared minus the sum of x squared. So altogether, that is going to equal b equals 6 times the sum of x times y, which is 2,746.5, minus the sum of x, which is 75, times the sum of y, which is 178.6, over 6 times the sum of x squared, which is 1,375, minus the sum of x squared, which is 75 to the power of 2. Once you've calculated that on the calculator, it should give you 1.17. So now that we found b, we can find a using the formula a equals y bar minus b x bar. The bar on top of the x and y means that you have to find the mean, meaning the average. So what you're going to do first is find the mean of y by doing the sum of y, which is 178.6, divided by the number of items, which is 6. That will give you the mean of y. So now that you have the mean of y, you can fill in your formula and find the mean of x. You're going to find the sum of x and divide it by the number of items in x, which is 75 divided by 6. That will give us 12.5. So now using your previous information that you got that b equals 1.17, you can plug it into your formula and solve normally for a. You should have gotten that a equals 15.04. Now that we found b and a, we're gonna go ahead and plug the values that we just found into the line of regression equation y equals a plus bx. Now that you have plugged the values into the equation, you have found your linear regression line.